Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh.
Hello and welcome to Advent of Code. This is day 17. Apologies for missing last night. The problem dropped at the same time that everyone at the company party was starting to give speeches. But don't worry too much because I'll post a video at some point of me solving day 16. So needless to say, I didn't get any points yesterday. And but that's all right because maybe we can get some points tonight. Let's take a look. Here we go. All right, spin lock. Algorithm. Okay, quickly consumes circular buffer containing only the value. Okay, circular buffer, current position, steps forward, inserts a new value. Before inserting the first new value after the value it's stopped on. The inserted value becomes the current position. Okay, then it steps forward the same number of steps wherever it stops, second new value, and uses that as the new current position again. Stepping forward, inserting a new value. Okay. All right, so let's talk about a circular buffer. Okay, total of this many times. 3 steps per insert. Then starts out at 0. Okay, steps forward 3 times 0, 0, 0. Then inserts the first value 1 after that. 1 becomes current position. All right. Steps forward. Okay, so not getting it yet. All right, so puzzle input is this. So this sounds like the number of times, number of steps. Okay. All right, so okay, so let's see. 1 becomes the current position. 2 becomes the, oh, I see. This is like now the current position. Okay. 3 becomes the current position. Okay, so I think it, okay, so, well, let's just see. Let's see if we can maybe write this algorithm that conforms to what we got here. So some kind of step for our state here. All right, so we've got 2 steps forward 3 times. I see. Okay. All right, so we can do that. So the state is going to have something like a buffer and a position. To the position, we're going to be adding 312, which is our puzzle input. And then I think we can find the remainder of the count of the buffer. This will tell us sort of where we end up. And then it inserts in the current position. So let's see, is there a, yeah, is there a, okay, so this sort of tells us, so got some n here. We kind of can probably just end up with a kind of like concat drop n to a list containing like only I, and then oh no, wait, I think probably take n and then drop n, something along those lines. And you have to do this 17 times. That should be fine. And then, so this is the new buffer. Then the position that you're at, 1 becomes the current position. So, okay, and then inserts the third value. Okay, and then inserts the first value 1 after it. 1 becomes the current position. 2 becomes a, okay. So I'm not seeing what is the difference between position and then this value I that we're inserting here. So I'll just do that and take this part out. So if we have our step starting with an empty buffer and position 1 like this, right? Divide by 0. Okay, maybe initial state before any. Okay, so actually, no, this is the initial state. All right, and then maybe like that, the value that you're about to start inserting, and then don't know how to create a seek from a take, right, of course. Take in from the buffer, drop in from the buffer. Okay, so 1, 0. Let's change this to a 3 just to verify that we're doing the right thing. All right, so this is wrong. Okay, inserts the first value 1 after it. So the value is 1. So we should be taking 0 here and then adding 1 to that. Why isn't this working? It moves forward 3 times. Okay, so I think it's because it comes right after it. So I think this needs to be like incremented. Does this work? Yeah, this seems to work. Let's take 5 of these. All right. Okay, and then this isn't working here. So right, so iterate is wrong. It's more like reduce step. Starting here, let's change buff to be like this. Here, here, and then take, we'll just give it 1, 2, 3, 4, 5. Okay, so not quite right. So the problem is that, so what's the problem here? We get the n value correctly. Seems good. Oh, right. Yeah. So this needs to be pulled out here. Okay. 012, which is wrong. Okay. All right. So in the second step here, we're receiving 2. The buffer is in the right spot. And then, so I think maybe the current position needs to be tracked as part of the state. So let's change this to the value here, and then talk about modeling position. So bring this back in. Yeah, something like this. Yep, and then so we're starting with 0 like that. Okay, 021, 0231, 04. All right. So let's change this to our 312. Then after 2017, what is the value after 2017 in your completed value? Okay, after 2017 insertions. All right, so we just basically need the range of numbers starting with 1 going up to 2018, and we just need to call reduce here. All right, let's put this in a buffer and look for 2017, the value that comes right after 772. Right answer, rank 208. Okay. back to the problem. Spinlock does not short circuit, it just gets more angry. All right, the value after 0, billionth, the value after 0, the moment this is inserted. Okay. Hopefully this will be workable here. And then to this 2-1 filter where the first of these things is 0. That should be good enough. It is 50 million here. Okay, and also this isn't going to work as written because I need to actually only get the buffer out. So the first thing here. Be good to be able to inspect how fast we were cranking through these. I think probably what we could do is something like open a different REPL here, and then do something like time this value going up to something like a value, well, 100 times the size. Uh-oh. So if this is already taking time, then that doesn't seem too promising, does it? Let's try taking 2 more orders of magnitude off. Huh. It seems like it really doesn't like this. Okay, 6 seconds to do 5,000. That's not going to work. All right. So I think that we're probably going to have to represent this as, probably have to represent buffer as a vector. So let's see. Okay, how do you take a vector, insert a value? So closure insert vector value. Okay, we got a Stack Overflow here. Okay, that's, yeah, this is not going to be a sensible kind of thing. Let's see, the buffer gets bigger each time. So it seems like it isn't okay to, well, maybe we can store it as, so if we represent the, so we can have something like an array. So we just had an array of ints. So I think Clojure has a function called int array. I'm thinking that we'll use like an int array. Yeah, okay, size or seek. Okay, so we'll have an int array of size like this big, let's say. And then what we'll do is we'll only use we'll like only use the values in the beginning, but then that's going to require us to, that still requires us to like insert values in here. It could be faster. Let's see. I wonder if there's any possibility of, let's stare at this a little bit. I wonder if there's maybe something about the fact that the relationship, there is no relationship between elements in this list. So maybe we could just represent everything as a, maybe like as a pair of the point that you were inserted at and like the time you were inserted at and the and the position that you're inserted at. So in that case, the buffer becomes something like just a list, and then we conj onto it something like n value and maybe just n in value. So what if we did do something like this and then emitted? I think we also still have to continue to emit the position here. So let's think about this for a second. So the buffer is still growing at the appropriate size. So if we talk about this here, okay, so this should actually be a list containing 0. Oh no, a list containing something like 0, 0 here. Okay, and now it's saying 1, 1. All right. Now it's saying 1, 2. Let's do a couple more here. This is this doing anything? So right now it's not. It's because it seems like n is always 1, which I don't think it should be. Take a glance here. Oh yeah, still cranking. I think we'll go on forever. So the size of this list should continue to be increasing. Let me just double check that I'm understanding this part here. Okay, so it's getting this part, and then the position is I see. Okay, so this is wrong. Try this. Take this out. All right. Now what? All right. Unfortunately, that doesn't really seem to be. Doesn't seem to be any better. What? I'm curious what the big difference is. Let me take this out for a second and examine it. Looks like we got some noise in the other apartments. Sorry about that. All right. So if we ask something like, if we just print out n here. I wonder how much it matters that the data structure that we start with is this. Did something change here about our algorithm? This seems to all of a sudden be giving the wrong answer. Yeah, that's the wrong answer. What did we change? Let n be this thing here. insert the value at this particular point. Oh, no, nothing changed here. It's just the fact that we're using 312. So yeah, so if I change this back, all right, so let's back up. Let's bring back this thing, this idea here, okay, but change this to 3 so that we can sort of observe the behavior better. Okay, now if we start with this being a list of 0, 0, then we end up with this here, which I think, if I interpret it correctly, means that the list goes 0, 2, 1, 4, 3. Wrong. So, all right, so at point 0, insert it here. Okay, and then insert 1 here. And this says basically insert this in between them. And then this says insert this at point at 2. Okay, so it seems, so definitely it does start at 0. Then 2, so 0, 2. And somehow then it's 4. And I think that's because, okay, interesting. So it's almost like if you can track how many points have been inserted at like the current point, maybe, then maybe that's workable. Like our data structure. So it does seem like if we like work over this, like in the case of if this 2, 4 here, then it's kind of like we know that it's going to be after this one. I wonder, yeah, I think this should work. The main thing is figuring out, so basically what value, okay, I think I see what they're going for. It's what value is directly after 1. So in other words, what is the last value to be produced that has an insert value of 1? So what if we just said if n equals 1, then def answer to be value. This. And then we don't actually care about the answer here. In fact, I'm a little bit, we don't even need to be carrying this thing around. No, we just need to be carrying the count. Well, let me try this. I'm a little bit worried that it's gonna run out of memory, possibly, maybe. All right, I think I can stop this. Okay. And then I'm going to define an alternative version of this function. So get rid of this stuff. I'm going to call this step 2. And then we're going to represent this by just buff count here. Buff count. In fact, the count at any given point is just equal to the value. So we really just need to track the position. Okay. All right. Okay. I like this. And then the position here is just n. All right. Go in here. Define step 2. Okay. Yeah, I think my JVM is running out of memory. Okay, I'm gonna stop this because I think this will work. Okay, so step 2 here. All right, and reduce step 2 like this. Okay. All right, and then I guess. Oh no, I definitely don't want to change any. Okay, persistent vector can't be cast to. Right. Yes, I have to call this with the right. So okay, position. So this just starts at 0. Yeah, just like this. Okay. All right. Yeah, here we go. All right, that seemed pretty fast. What do I have for an answer? All right, let's give it a try. Hey, right answer, rank 305. Okay, all right, pretty cool problem. Yeah, let's talk about it. So, yeah, so this is a state transformation problem, where basically at each point you you manipulate a circular buffer by inserting a value into it. Yeah, so like, for example, one good implementation of this might make use of linked lists to make those insertions more efficient. Would it? Maybe. So basically, at each step along the way, if you did that, then you'd have to follow 312 pointers, which may work for part 2. But in any case, you can see the that basically at each point, at each step in the process, you're sort of spinning your position ahead a fixed number of things and then inserting the next value. And when you spin your position ahead, there's some modular arithmetic that's going on there to tell you what the index is that you end up at. So they provide an example. I think I was pretty slow on understanding what was going on, so I made sure that my implementation matched the example that they provided. Let me compare to the times that people got today. First star, 2 minutes. Okay, all the way down to about 6 minutes. Okay, so maybe I wasn't so slow. I think I ended up with well, I can actually find out. So it looks like, okay, so it took 9 minutes for me to get the first part. And then yeah, the question was just if you follow these instructions 2017 times, then how what value comes after a certain thing. Okay, so then and that was straightforward. And then in the second part of the problem, it says basically follow this algorithm 50 million times and then tell us what the value after 0 is. So similarly to day 15, part 2 makes the problem harder in one way and then easier in another way. And there's this sort of key insight to this. So basically the key insight is that you don't actually have to build this buffer if you can just generate a sequence of insert instructions. And you can. So for example, in the example, this is a sequence, it's backwards, but this is a sequence of insert instructions saying basically insert 0 at position 0, then insert 1 at position 1, then insert 2 at position 1. So then you end up with 0, 1, 2. Then insert 3 at position 2, and so on. And it's possible to generate this sequence of numbers using not a whole lot. You know what the size of the buffer is at every given point because it's your input, and you know your state is basically just your current position in the buffer. So it's certainly possible to like just generate this whole sequence, no trouble. So given that, they have made things easier for us because they just want to know what the value is after 0. Well, the value after 0 is just the last time, because we know that 0 is at position 0 in the buffer. Nothing moves around. So the value after 0 is the last value that was inserted at position 1. And there are a few ways that I could have done this in a in a more idiomatic closure way. Here we go. The first way that comes to mind here would be like, instead of tracking only position, we could have position and then like answer like this, and then have our check here return position, or here probably like n value like this, and then otherwise just return n and the answer that we already had. So in this case, so I'd have to tell it maybe like no answer to start. This should return pretty quick. Yeah. So what is it? I see. Yeah. So basically, this doesn't change the answer if n is not 1, and it does if it is. So yeah. So this gives us the answer as well. So I really liked how the second part of the puzzle sort of, required that insight. How long did it take other people to get it here? 17. All right. Okay. So between 5 and 15 minutes. Okay, that's pretty interesting. Yeah, for me it took almost 25 minutes to get this part. I wonder if some people just brute forced it, if they were using languages and data structures that made it easy to just do the 50 million inserts. Yeah, that'd be interesting to try. Like if you actually had a linked list data structure, and you were doing like just the pointer traversal. I guess I'm just not sure. So 50 million times 300. Yeah, I mean, seems like a lot of computer operations, but who knows? And there may be approaches that I haven't even thought about yet. But this of course does seem to be like maybe the approved answer. I don't know what there might be an even faster way to do it. be a little bit surprised though, because it does seem like we're doing. It doesn't seem like we can do a whole lot less work than we're doing now. We're tracking basically 2 numbers of state, and we're just doing arithmetic on those numbers. So fun problem. Fairly quick day, quick night, and I'll put up a video at some point of my solution for part 16. It'll be nice to solve a problem at a slightly less frenetic pace, and hopefully I'll be able to maybe produce some good code for a change instead of just fast code. All right. Well then, keep your eye out for that video, and I'll be streaming this tomorrow. All right. Thanks for watching.